conditions are put in fancy name, that is machine learning. Yeah, that's some sort of true. Okay, so what we want is over here, we want this is system to learn from the previous experiences and then improves it for the future and in order to help you out. So if I say loan detection systems, or I say fraud detections, spam emails, if I talk about tagging you in your Facebook post. So knowing this is kind of all things happening with the previous experiences, because you have might have tagged your friend in the previous experience and then it is going to tag you in the future automatically when you're going to have a group photo tag. So what machine is learning that you have tagged this person or you have detected this person as A. In the future, when you're going to come with the same person, it is going to say this person is A. He's no matter he's standing like tilted or whatever the way you are just putting, but it will try to detect as A or B. Sometimes it is detecting like, but 99% times it is going to be right. Okay, because one person can it be wrong. It is a machine, but ads is specific to your search. YouTube history is specific to your search. So it's all machine learning, deep learning algorithms which are combining. But we don't have to move to deep learning right now. We just have to move to machine learning. So machine learning is basically just your previous experiences going to help you out to learn for the future action course. Okay, so it is just a prediction which you're going to make on future work using the previous experiences of yours. So this is machine learning. So people say, what is the difference? How does AI makes a difference? Because AI has separate base. So it is just machine learning is just a minute model for AI, or I say deep learning is minute model inside the AI, because AI is a big fish. So it is just there are small fishes running around, and there is a whale coming that is AI, and it is eating everyone. So it is like that. Robotics is also one field that is under AI only. So people say robotics is a very vast field, but I say inside the AI, these are small batches which has been made in order to make people learn from one step to the another step to move into direction of a good engineer or a good data scientist. So they have to spend a lot of time on pre-processing of data. Sometimes what happens, suppose you're filling IIT form when you're just applying for IIT, JEEs, mains, whatever, any kind of form you're filling. So you don't put up you don't fill up every blank, because sometimes blanks are not mandatory. So you left them out or leave them out. So when you leave them out, and some people fill them also. So what happens? The data is having some things messed up. So when you are going to be like talking about the data, what I need to say is I want to fill those missing values, or either I want to remove them, or either I want to handle them so that they should not affect my prediction result, or they should not create a problem in my prediction results which I'm going to do in the future. So it is same thing. Your teacher is having intuitions about us. When we talk about intuitions, it means like whenever teacher comes in the class and she takes a test and she got some marks, so she has some intuition. This guy is going to get good marks. She says he's the topper, or he might be going to get good marks. But you will second person with the second, he says the teacher says you will not get good marks because you don't study. So teacher analyzes your study patterns, class behavior, class work, the way the person deals in the class. So this is also a kind of machine learning with a classical way, or I say just without the code, a teacher is analyzing a person is going to fail or pass. So if person get top also, no problem, because sometimes things can, like some people really study one like overnight and then they do the topper work. So that's a different case, but in 98% cases, teachers are trying to predict for a student. That's how the machine learning works. You have some data, you make the data to understand and make the work to be done in this order. So now if I talk about, if there is one of the huge e-commerce giant, that is Amazon. What is happening with the Amazon? Very good example. I say, like I did a research study on this Amazon. So there is a sales engine. So if I'm talking about the sales engine, it means Amazon having some categories. Suppose there is a electronics category, kids category, footwear, everything is there in the category section. So they want to understand if, if they have to spend like $1 billion on my on sales, or on say discounts, so or on say marketing, everything combining. So where they should, what is the previous revenue they got, and if they put this in this, what amount of revenue they can get right now, or if they put up in electronics, they didn't got this much amount of margin. The they way they amount the put up the money over there. So that's one typical case is when we talk about the sales engine, it all depends on the sales. You see the sales over there, you see the proper losses, or you see what kind of margin you were getting. So this is all predictions for the future, the amount of money I should put over there and I should receive. This is just on based on the patterns. Okay. So this is all machine learning where we have the data. We have ample amount of data. We clean up that data just to remove the missing value or anomaly values. Basically, I say like the duplicate values, and I change the I say the extra values to the useful patterns, or I say I make the class labels properly. So it is going to be turned out, and using those experiences, I want to take future action. If this happens, do this for me. So this is called my machine learning. So a machine learning from its previous experiences. So there are two definitions. So it's a study that gives computers the ability to learn without being explicitly programmed. So we are not programming for every single data column row. We are programming for the entire thing. Once we're done, they are going to do it for automatically. So it's going to be like a continuous process. It's going to happen every time whenever there's kind of same kind of data which is going to come. Okay, so in 1997, the definition was more improved, I must say. So it's going to be set to learn from experiences with the respect to some task. Performance measures P on its P measured by P improved with experiences. So it's all about the experience improvements in the future to take the necessary action. Okay, so now so why ML is becoming, because there is data mining of data, big data also, that is one that is a fish which has been eaten up by machine learning. So if I talk about so many things has been like I said degraded because of this machine learning. So many things have big data has its own uses, but now you will not hear a lot about big data rather than about the machine learning part or AI part or deep learning part. So what happens is because the predictability or learning becomes easier in this, because there are a lot of tools available, there are a lot of plenty of solutions available in the market. So if I talk about handling the huge amount of data and creating the patterns into it, in the data mining application, data mining field, we are using natural language processing, the chatbot. Alexa is my favorite. I don't know about you guys, which is your favorite. So please do just check it out. The Siri, that is amazing. So, and if I just talk about the Google Assistant, that is also great. So that is also one part. That if I just talk about the Rasa chatbots, which is open source system, that is also amazing. So you all can just go over there and sign it and work it out. So there are plenty of places where natural language processing is comes in phase. So if you just go on to the ICICI Bank application, there is also a chatbot. Swiggy, there is a chatbot for their order problems. Amazon is also having a chatbot. So there are plenty of chatbots which are working in the all around. So why they are taking this? Because there are few specific cases which they have seen the questions and they don't want somebody to sit and give the answer. So what they do is they manually, or I say they program it in such a way so that understanding between a human and a bot can be made. So what we were lacking in the past when we were just talking about the chatbots, there was no sense of okay. I talk about the natural languages. A natural languages means contextual based understanding. So contextual based understanding is if I'm writing those few words, but in any order. So in any context I'm writing, it the bot needs to understand. Now we have achieved using the deep learning such a technology where we are able to just find it out according to users, according to the context, the answers we can replicate. So if I just talk about, because my favorite is Alexa. So Alexa works on LexBot. Lex works on the Poly chatbots and Lambda functions. So that is where the deep learning phase comes in. Or I say Microsoft is also having their own, but because I want to have the convincing languages, so I always prefer Lex, where we have a number of context-based understanding. So there is neural sites which it understands and gives back to the reflection. So image recognition systems. So if I say beautiful example, the example is automatic number plate detections done by government challan system on the highway. So I don't know how many have faced it. So I hope, and it's Chandigarh or I say Punjab, there is few places they have implemented. So on the highway, Yamuna Expressway, I've seen that. So if you're crossing the speed of 120, the speed sensor gets enabled, and there's a camera which clicks on your photo, and it detects the number plate and gets the details of the owner, and it sends a message to the number assigned. So this is one use case. Or barcode reading, that is one use case. If I talk about wine menu reading, where this bottle people or say huge in the alcohol industry is trying to come, where is my bottle in the wine menu, which placement has been made. Or I say Reliance Store is trying to get to the understanding of the sales, where they put their product, expensive product, or where they put the cheapest product to get the sales higher. So like Walmart is doing the same thing. They need to understand the human behavior by using the computer vision systems. So that is very amazing examples people are trying to use in the patterns. So Uber is having one. It's a very amazing company which is using all those materials for the recommendation systems. So I forgot to tell about the recommendation. That is my favorite part in Flipkart, or I say in Amazon. What happens with recommendation systems? So if I generally talk about recommendation system, what happens over there is, so suppose I'm buying an iPhone, or let's just not talk about iPhone. Suppose I'm buying a phone, general phone. So there is suggestions of getting a back cover or wireless earphones. People have bought this. Okay, so there is a suggestion feed downside. People have, those who have bought this have bought this also. So if I say in YouTube, the recommendation is based on your history. So that's where I say pattern is. So this is YouTube history, which is I determining my work and what my text. Okay, it's not video. It's on the basis of text search. So whatever the kind of text search, they are categorizing it. Suppose there is a romantic text search or text search, or if I'm just talking about the crime scenes text search, is Netflix also do the same thing. We have bought it for you. So if you see the Netflix option, we have bought it for you. Your collection, your, so they first of all they prefer your collection type. So if you're searching like thriller movies, so next few movies are going to be the thriller ways. So this is recommendation systems. So ML is providing these kind of potential solutions in all these domains, I just say, and it has been exponential growth in that. So if I just talk about these are the four key areas which I thought that is going to be workable. Okay, so machine learning is just the learning environment from the experience, but it has been divided into three learning. So when we talk about three learning, it depends on your input data and the target. So what is my target? What I have to predict. Okay, suppose I have the height and weight, and if I have to predict the weight, that means it is my weight is my target. So feature is my height. So feature is always on using those features. I'm going to predict my target. So target is always going to be which I'm going to predict for the future. So that's where the input is going to come in phase. So input is my features and output is my target value. So there is three different styles in machine learning: semi-supervised, supervised, unsupervised. So some people have heard about the supervised and unsupervised, but semi-supervised is like less heard. Okay, so I have got it like graphs also. So semi-supervised learning is basically labeled and unlabeled examples, or I say, so organizing the data in, because you don't have the data organized, you need to organize that. So semi-supervised having classification and regression. So that two words makes a lot of sense, and the whole machine learning works on these two things: classification, regression. So if I say I have my output is a continuous value. If I talk about my output, it is a continuous value. Or if I say my output, it is in two things like spam, not spam, or pass or fail, 0, 1, green, blue, what like 2 or 3 maximum label I have, or maximum 3 categories or 4 categories I have to define my output. So it is 0, it is 1, it is spam, it is not spam, it is pass, it is fails, it is called classification. So if I say, if I have to predict the price for the house, if I say I have to predict the salary for the person which is having 5 years of experience, this is regression. My data is continuous. So that's where the regression comes in phase. In classification, where data is not continuous, it is divided into categories. So category means your shirt size is small, medium, large. That is classification. Regression is basically my category. I don't have any category. I have the continuous values. Like I have to predict the price. I have to predict the marks. I have to predict uh, like I say loan predictions. Sorry, loan prediction in two ways: how much amount of loan and how much amount and what the loan is, if he's going to get the loan or not. So if he's not going to get, if he's going to get the loan or not means it's a classification, and if he is going to, if I talk about if he what amount of loan is going to get, it is regression form. So classification is C means classification means categories, and regression means continuous values. So these are the two like kind of typical problems we solve in this all areas. Okay. So in semi-supervised, we have labeled and unlabeled examples. So what do you mean by label? Say like I have organized and the proper output, I have the structure, and I know what kind of output I'm going to get. So supervised is basically, so what I have is training data. So there is a term that is training and testing data. So if I just talk about, we were talking about prediction. So how prediction is made? So if I say how prediction is made or how prediction has been done based on my training experiences. So what is training? What we do what we do typically, what we first of all, let's start. We analyze my some modules. Modules mean my libraries. So libraries means my packages. So if I talk about the language, that language is Python. I'm not sure whether your college is providing you Python, but Python is going to be the future language, one of the main language. But for machine learning, for deep learning, this language is taking a deep forward front, because Python, because of the Python language, people just try to move into this career. Otherwise, people prefer R also, but for as a, if I say instructor or as a guide, I always prefer to go with the Python, because you learn a language and then you move on to the end applications of it. So Python is a language. So what we do when we just try to categorize a model or try to make a model. So what is model now? So model is basically where the training has been done, and testing is where the prediction need to be, or the real data where the prediction need to be made. So what happens when we do the training model? So in that training model, what we take place is we like call our first packages. Then after that, we call our data. Like if suppose I have the CSV sheet, or I say I have so many other like CSV, or I have an Excel sheet. I have like 10 things, or a CSV, any kind of format data, or I have a API reference. So I want to read my data first. I just call my data and read it. So after reading it, I analyze my columns. I check how many missing values I have. I want to fill those missing values. I want to encode, or I say I want to label my columns. Then after that, what I get is I prepare a model. So I just call my training method. So I will have like a few percentage of my data, because we cannot train the whole data, because that is not going to give me any accuracy, or that model is going to be blunder, because when we train the whole data, then how the prediction is going to be tested out, or how the model has been worked, how it is going to be tested. So suppose I got a new car, but I don't know how to drive. So what is the use of having that good sports car or good different like the good car which I have bought? So the best part is always whatever the model I have made, how to analyze the model is good or bad, or how the model is performing. So for that, what we do is we leave the testing data other side, like 25% or 30%, depends on our data, how much data we have, and training data other side, like 80%, 60%, 50%, 40, 30, whatever the data, but we always keep a ratio of 80-20 or 75 to 25 percentage. So we take the 75% training data, and we take out according to the algorithm what kind of mathematical method is happening. So now if I use the mathematical word, try to understand one thing properly in a machine learning, what happens to the mathematics? The whole system or the whole machine learning is a pure maths. So just people say now it's not compulsory to learn maths. But if you're going to question why this is happening, then there will be an answer that's going to come out from the math side, not from other side, because that took me around 1.5 years to understand machine learning using maths. I took 1.5 years to understand machine learning using mathematics, because it's a pure maths. Because whatever is happening in the background, it's either me or in the different differential equations, or I say standard deviations. These all are happening as a mathematical base. So we have used them and called them in a particular file. We have trained it just to, whenever it is going to be passed, that's the data is going to go through those equations and going to give me a some point or a predictable result. So that's how my training is happening. So if I pass like any algorithm, suppose it's linear regression, logistic regression, multiple regression, or I say polynomial regression, I say K-NN means, or I have a gradient descent, SVM, support vector machine, whatever. So it is all having the different capacity or different mathematical base, which is going to treat my input data or my training data in order to fill my work for telling my data what to do or finding the pattern in that data on the basis of my mathematics. So this is always keep in mind. If you're learning this, just try to read some blogs for maths. Okay, because without maths, it's going to look like something is happening. But what is happening in the background? If you don't want to know, it's okay. But for your goodness, for your work, mathematics is required. Okay. So because nowadays also like a lot of people are there who knows coding very well in this, but when it comes to the point of putting those code in one understanding and telling someone, okay, this is how it is happening, somebody asks why it is happening, nobody can answer that, because I say 70% people don't know, because they learn the code very well, but they forget it out the mathematics at the different phase. Okay, so in supervised learning, we have all the things labeled up properly. So this is also having classification and regression problem. Okay, so there the accuracy is, so there is one word, that is one accuracy. What do you mean by accuracy? So it's not like if I have accuracy, it means corrections. My accuracy means, if suppose my model is producing 95% accuracy, 95% times my model is going to give you the right prediction. But except that 5% times it may be wrong. So 95, whatever the result is going to come, suppose it is spam or not spam. So if it is 95% model correct, then it means whatever the answer is going to say, if it is saying spam, so it is 95% correct, but 5% might be there is a problem if it is not giving the same result which you are expecting. So your expectations always depends on what kind of model you. So that's why you say in Kaggle. So there is a platform where people learn or just use the coding or data. So Kaggle is a wonderful place. So you just go out over there and explore a lot of stuff. Like there is a Titan data set. So many data set is there. Then there is possible solution which has been given. So what we say the possible solution for the baseline model. So baseline is where you prepare a model and after that you give any data set and it's going to work in your way, in your desired manner. So exploratory EDA, exploratory data analysis. It means you load your packages, you load your data, you load encoding techniques, and you load missing values, and you just enable the encoding techniques. And after that, you call all the models whichever you are preferring. This is called exploratory data analysis. So this is one of the finest thing which everyone should do when you're preparing, because you should pass the comments in that, and then you're going to understand how this is happening. So when we have training data, we train, and then after that, we want to test on a real data, or I say the 25% data which has not been touched, to know whether the prediction which is coming is going to be right or wrong, or it is performing well or not. So that's why we just divide the data into training and testing. So training is happening on 80% data or 75% data where there is math or algorithms working, or I say some regression technique is working and it's going to train certain things to a network, and after that this is going to be trained and there is accuracy has been generated, and that model is going to be tested on the test data which has not been touched or nothing has been generated on that data. So there is unsupervised learning. So basically all I say about this is k-means, or I say nearest neighbors. So in this, the data is not into a form where it is systematical, or I say there is a videos which are there that has not been organized, or there is no photo data that has not been organized. So the system is not able to read them, or system is not able to define the data. So this is basically, so whatever, so it is like astronomical data, that is unsupervised learning. Or I say basically the data which is uh, making cluster or genes specification or gene detections, like creating different genes by using those. These are, that is also unsupervised learning, because you don't have the specific data which has been any order or any specified. So always the data is there in the mathematical format or a tabular format. So apart from that, whatever the data which is not there in tabular format or systematic format, which I talk about, systematic means the data has been organized with the labels and classes very well. So that is unsupervised. So unsupervised topic of a lot of research is going on. So there are few algorithms, the a priori algorithm and the k-means, but a priori we don't use much. K-means we use. K-means is clustering, making specific cluster using the nearby. Suppose my group, so what we, how we choose the groups, or how we choose the clusters. What happens with the clusters is, so if you see this, so there is, suppose I have red, green, and blue boxes, or I say I have three boxes, red, green, and blue. If there is another box which comes, so how to find out that box is going to be in the red, green, or blue section? So for finding out that, what we do is we pass on the k means. So we make clusters. Suppose red cluster, green cluster, blue cluster. So then after that we make a center point, and we want to find out the distance of that black from all the center points of the other are red, blue, or green. So the black is going to detect it. Whatever the nearest point is going to be, it's going to go into that. So that's unsupervised learning for us. That is k-means clustering methods. Or I say there is a rule-based learning which is happening. So there are specific rules for making it to learn. But when we talk about the specific rules to learn, so there the points come in your mind. What is rule? So you make a rule, or you make an exception for it. This should come, or this is not going to come. This is going to work, this is not going to work. Or this is going to be in one category, this is not going to be second category. This building A is in one category, B building is in one category. So you're making clusters, or you are making the rule for it. This building's person is going to be allowed if they're going to show their ID card. This building's person, B building's person is allowed when they are not going to, when they are going to show the barcode. So you are making the rules according to the buildings, or to make it differentiate between different clusters or different work. So unsupervised is research topic. Basically, all our work goes around in supervised learning or semi-supervised. But the main point is you need to understand either it is a classification problem or either it is a regression. So for that, you need to just go on to the output, that what kind of output it is asking. Either it is categorized or either it is continuous output. So when it is called categorized, it means it is asking spam, not spam, or two or three categories it is giving. So it is a classification problem. And when it is saying it is continuous, it means it is a regression problem. Okay, so we have basically a learning system model. What we take up the key elements is, we have an input, we have a learning element, knowledge base, performance element, output, feedback element. And so these three things, when we talk about the starting thing, when we say what is the input we are passing, or when we say learning element, so learning element is just analyzing the categories or the patterns into that. It learns from that patterns and put at that into a knowledge base. So when we have the patterns and the specific knowledge from the previous one, it's going to tell me this is happening, this is, you have to take care. After that, it boosts the performance by which is in phase. After that, it gives the feedback for the desired expected output to come. So this is basically a I say this is an old model, or I say this is the specific standard model which we need to follow, which we have followed in the previous. So what we give an input, after that this learns the categories or patterns into it, so that it can just pass on to the knowledge base, where then after that it can boost the performance element, and I'm just going to pass on to the output. So training data and testing data, what we have worked it out. Okay, so training data. So there is now, if you see this one, so what we have is we have the linearly separable data. This is non-linear separable data. It is hard. Okay. So for this, what we can separate it out, but we have to omit out some elements. Okay. So training data, this is training set, this is testing set, this is universe. So this is the data which has been given to us. So what we are doing is we are dividing into training, and then we are just doing the testing. So testing is unobserved. This means the testing has not been touched or nothing has been done. In training, we have done the categorization of labeling, or I say we have done the missing imputations, or we have done the encoding part. We have passed on the algorithm parameters, and then we have made it in such a way so that it can give me a accurate result on my feedback systems, or I say on my output system. So when I'm going to check my output, I'm going to test it on my testing set, which is unobserved. So this is the way where you can work it out on training and testing set. So there is a training test split feature which is there. So now what we have is artificial intelligence, machine learning, and deep learning. So big fish, small fish, and then another small fish. So when I talk about AI, it is the prediction plus probability feature. Okay, deep learning is basically the neural network, or I say uh, like making a brain-like structure which is made of neurons, or I say made of data, or the neurons which is passing. That is deep learning. But in AI, what happened? So how does this AI derive? So IBM's Blumex and Gary Kasparov, they were playing chess. So IBM Bluemix was a player they made by using AI. So Gary Kasparov, one of the finest player of chess in the past. So when they were just talking about the AI culture, what happened is when they were playing chess. So what happens like in a human tendency, in a human brain, when somebody is losing one side, or I say if I'm making somebody to lose in any game, I will try to make them lose badly, because every time when I know, okay, this person doesn't know this one move, I will just make them to my perfect moves to defeat that. So Gary Kasparov also thought the machine, this is the dumb machine which is not able to play. So he finished up the chess game in 4 moves also, because chess can be finished in 4 moves. So he played his 999 games with the IBM Bluemix bot. After 999 games, the bot you were not like Gary Kasparov was not able to defeat, because the bot learned from its previous moves, because the moves were probably fixed. But after that, when the moves were probably fixed, the things which were changed was the robot or the bot was trying to know itself, is this happening? Is this I have to play at this time? I have to play at this time. So in 999 moves, it learned in 999 games, it learned what kind of moves we have to play, what kind of things which we have to look forward. So that is where the AI comes in phase, or taking the decisions at the right time. So what happened if suppose I am just making you to play this thing, some any game, and I'm the newbie in this game and you're the pro. So you will make me to feel like, okay, let's play in my way. Whatever the way they were playing, they will play a number of games. And once I'm going to learn every move, then at the next time I will apply on you. And maybe this is I have a prediction, or I say I have a probability that is fixed. Either it is going to be head or either it is going to be tail. But when it is going to be head or when it is going to be tail, that I need to learn, that I need to define for it. So for defining that, for learning when it is going to be there, I use AI. So that's the algorithm which teaches AI. So deep learning is neural network technologies, which is very required for image processing, image computations, or I say in the image object detection case. So deep learning has been mastery for the image spaces. So that has grown up because of images. Okay. People have applied for the unsupervised learning, or I say classification problems or regression problems, but mainly the use cases for deep learning is always the ImageNet system, ImageNet data bundles. That is me there. So I'm sorry I didn't saw the chat box. Now I'm able to see. So I will answer all the questions. Don't worry. Okay. So there are a few questions. HP, Archana, Goel, ma'am. Dr. Pooja Mohan, ma'am. I will just give this answers. Let me finish my things. So when we talk about are platforms where you can work it out or learn these things. So there is Python for the language learning, and there is Anaconda for the bulk side. So when we talk about in technology terms, it is like the Python has grown up into Anaconda, which it is covering a lot of modules like uh, Python. It is covering like Jupyter Notebook, Jupyter Labs. It is covering R. These are kind of things which is there. Spider is there. So this is basically just for the test platform, that is Anaconda. So you all can work it out on Anaconda. That is great platform. So Jupyter, I always prefer everyone to use this Jupyter notebook. It is interactive programming. So it is a local host network system. You can work it out. So for the people those who want to learn the language and they want to prefer, that RStudio is amazing. It has a lot of tools, but you don't learn a language. So it is just a statistical tool. So the difference between a statistical tool and a language is statistical tool is having the mathematical conversion technology, and language is having the ability to just manipulate in your own way. So there are a few startups which have changed the whole world. Okay, so there's 90 startups that is transforming the AI. There is healthcare startups have taken up. So we say NetMax is one of the great startup. AI Cure is also a startup. It is great. So there are plenty of startups which has taken care. So if I talk about the big names, that is Google AI. Okay. So Google's AI, if you want to check, that is great. So Uber and Lyft is not. I don't know about India. Lyft is not there. So Uber is also great for the AI use cases. That is basically the chatbots. They have implemented the ride sharing or the create like location options, the how they want to locate and how they want to peak the traffics. That is Google is trying to do just to pass on. Okay, so email categorization, or I say inbox, primary, secondary, and I say what I say social. So that is the smart email categorization using basis on your work. And if I just want to say, Facebook is having the geo bar tagging system. So search engines, it's always clear search engines uses from the past only, but now they've improved a lot. So Amazon is using recommendation, voice to text, and medical field recommending medicines according to your health or recommending doctors. That is also great. So this is my conclusion. So this is some techniques or algorithms machine learning. This is going to help you out. So point is very clear from my side. One point, just keep in mind always. Machine learning is not a 1 day work or 1 hour work. It is like a whole day or whole year. You take it out, work out daily, and then to come you reach onto a specific conclusion and come out. Okay, this is I have learned. I can apply it in real time. This is I have learned. I can apply in real time. This is I have learned. I can apply in real time. So for so many things are there where you think of to apply. So when we need to understand how this base is working, either with the maths or either with the code, then you can just think of this future. Machine learning, or rather, I want to be in an AI department. So machine learning is pretty much easy, but data pre-processing takes a lot of time. I can just say probably it's took me 6 months or more than that to understand the data pre-processing. So I might be slow. So I will not say everyone has their different ability, but 6 months it took me around to understand data pre-processing, where I was just reading out pandas, numpy, scipy, like scientific Python or scikit-learn modules. I was learning different modules, and what they are doing, that is a very deep thought. So when you just want to learn, you need to understand the data pre-processing first. In the first beginning, 75% of your time goes in the data pre-processing. So whenever always the school college teaches you Python for 6 months or for the whole semester, whatever the way they teach. So keep in mind the use cases you want to use with the Python, the end application you want to relate, the API usage of you want to relate. So GUI uses you want to relate, the SNS style sheets you want to use. So you need to be very clear with the Python, because when we learn Python, we grow up in seeing that there is a language which is very easy, but how we can utilize it for our purposes, that is very different. So we learn that is different, but how to apply it for a purpose, that is different at large. So always remember, like whenever you want to just use those languages, just keep exploring it. Read out so much. Read out not a book, but read out blogs, because books are limited with the information. They will not grow. Because blogs are, they every day they grow, or they are people who just write something whenever they get new. Okay, so everyone cannot write a book. I agree, because books are very hard, because they do a lot of hard work for months and then they come and write. So books are different. I'm not saying not, just like, don't get me wrong. I'm not saying just to read, don't read the books, or just don't study from the books. I'm just saying read the books, do the work, but read blogs also, because blogs or Python has a very strong community. So that's what they post properly, and then they come out with a specific result of it. Okay, so that's my conclusion. So one of my favorite person has given or written something very amazing. So he's the NVIDIA CEO. Software is eating the world, but AI is going to eat the whole software system. So this is my favorite person, because NVIDIA is great, creating a good role in just providing AI and ML techniques. So I hope you liked it, and I will have question and answers now. So yeah, thank you.
Yeah. Thank you, Manoj sir. It was a great session. Machine learning is very clear to us all now, I'm sure. In such a short span, we have understood the topic. Now we have some questions in the chat window. Uh, First question, Archana ma'am, she is asking, how can we tune hyperparameters in deep learning?
Okay. So when we talk, Archana ma'am, when we talk about the hyperparameters in the deep learning, so it all depends on Keras model which you are using. Okay. So when we talk about Adam or the input size, that is one thing. We need to understand which kind of activation method you are using, or if you are just using the if you're just using the activation techniques, that is old, or you just check the try current trend in the activation techniques. So when we say about sigmoid, it is working, or Adam, it is. So you need to understand first the activation technique. The second point which I want to raise is the check the input sizes of the work which you are doing. Is it taking the same input size, or is it taking the same input methods? What is taking the parameter? That's the second way of tuning a hyperparameter. Then we have is SGD methods. So gradient descent method for optimization. So you need to understand that which optimization method you want to prefer for your work. Okay. So like I prefer SGD because that is very good, which is working it out. So you need to understand it is working for you also or not. So basically in deep learning, if you try the combination of a model plus a machine learning part, that is going to be amazing. So for that, you should take care of your hyperparameter. These are 3-4 things which you can do, because rest are not in your control. So that's the 3-4 methods you can try to put it up, or might be depends on your what kind of work you are trying to do, because I'm
Mhm.
talking more about the image context. Okay.
Yes, sir. So related to this, we have one more question. Like, which deep learning algorithm is best for sequential classification problem?
Which deep learning algorithm is best for sequential classification problem? So in when we just say in sequentials, in classification problems, so best, it depends on I cannot say which one is best, because there are, everyone is best at their own work. Okay, so LXNet or ResNet 50 is amazing. You can just think for ResNet 50, you can, that is you can handle a huge amount of data. That is amazing, but it depends on what purpose you are trying to solve. VGG's 19 is amazing. It gives a good result. Previously in 2016, it was the winner of ImageNet bundle, and in 2014, 12, sorry, VGG 16 was the winner. So you can see the patterns are there. So ResNet was recently launched, and it is amazing. So ResNet 50 I prefer moreover in VGG 16 and 19, but sometimes ResNet 50 doesn't work, but VGG 19 works. So it depends on your data set, what kind of data set you have. These are the few, like 3-4 which is there. In AlexNet is also good, and GoogleNet is also good. You can work. LaneNet techniques are also good. This is old, but that is workable and doable. So these are 3-4 techniques, but for me, it's ResNet 50 works. So you are using the softmax classifier.
Yes, Archana Goel, ma'am, she is using, sir.
Okay, so no problem. Just try to switch to different one. You might
Yes,
have,
sir.
I don't know your problem, so you just mail me your problem. That'll be great.
One more question, sir, from Pooja Mohan, ma'am. She is asking how to ensure that our model is not overfitting.
So overfitting and underfitting are two I say one of the dangerous problems, or I say makes a model worse if it is not properly handled up. So if you want to ensure, you need to have the progress bar. Okay, make sure you have a progress bar launched in your in your code, so that and you should have your system or in your code, you should be able to check or monitor the results which you are getting. So in every epoch, whenever you are going to check the result, suppose if your progress bar is there and when you have classified, and after that you are checking out your result on every epoch, and check out the graph in at every epoch and put that in the cache. So every time whenever you're going to check the graph, you will see after 25 or 30 epochs and use the early stopping in that. So when you're going to use the early stopping, that is going to recognize the patterns and it is going to stop if it is not training continuously or if it's not training properly. So that's a useful method. So we say early stopping is the best method to handle the overfitting or to monitor the overfitting or to do the baby train in the overfitting. We use the progress bar system, and monitoring technique is always check the graphs with the cache system. So when you have the graph with the cache system, you every time can realize the data is moving or not after a few epochs, because after generally the data doesn't move after 25 or 30 epochs if you're using the 100 epoch at that time. So it depends on data also, by the way. But for every time, if you want to use, just put the progress bar and put the monitoring system by using a baby train, because last time I was teaching this thing only, overfitting and underfitting. So that worked out with the progress bar only. Okay. So Pooja ma'am, I might can give you, if you want, I can give you a link. So that is where you can just check it out or put in your code that you're going to handle. You can handle by using that specific code into your model. That is going to work out.
Yeah. So I hope all the participants has got their answers. And now, thank you, sir, for answering all the questions so very well and sharing your knowledge with us.
Thank
So
you
we
so
have
much,
come.
ma'am.
So thank you for sparing your time. Now we
Thank
have
you.
come to the end of today's lecture session, and I would like to thank you, the speakers, for the informative sessions and the participants for being such a wonderful audience. And let us meet all again tomorrow at 10:45 a.m. Sharp for the lecture on IoT and security by Dr. K.R. Ramkumar. And for tomorrow's schedule, we'll be mailing you all the details in the evening. So let's sign off for today and meet us again tomorrow at the same time, 10:45 a.m. sharp. Thank you so much.